following program, the accumulator contains is 10H before executing this particular program. So what will be the accumulator content after the execution of pop instruction, which is located at 2007H? So first of all, what do you mean by PSW? We have to know. PSW is nothing but a 16-bit resistor whose higher order byte is nothing but an accumulator, whose lower order byte is nothing but a flag resistor. So before pop PSW, we are pushing the contents of B into the stack top locations of the stack. That is 20 FF and 20 FE 0100. So pop PSW means this is 00, this is 01. So pop PSW means the lower order byte is loaded into the flag and higher order byte is loaded into the accumulator. So the accumulator content after execution of this particular instruction is going to be 00. That is option B is correct. So what are the stack pointer contents after the execution of the call instruction? So here before call instruction we are performing one time push B as well as 2000 at location 2007 we are performing pop PSW. So these two are exactly opposite operation, so stack pointer is not going to be affected because in case of push B it is decremented by 2, in case of pop it is incremented by twice. So while performing the call 2064 instruction, it stores the next location address, that is 200E, into the top two locations of the stack. That means the stack pointer address is incremented by, here this is 200E. So now the location address is 20FE, that is option B is correct. It is shown in figure. Given omega as 5000 radians per second, construct the admittance locus diagram. So if we look into this one, the total admittance is nothing but the admittance of this branch is Y1, admittance of this branch is Y2. So YT is nothing but Y1 plus Y2, which is 0.417 minus J.0188 plus 1 by 4 minus JXC. So if we plot, Y is nothing but conductance plus JB, that is susceptance. So here this is going to be minus J.0188, this is 0.417, this is the Y1. Here whenever XC is infinite, so this is 0, XC is 0 means 0.25. So it is kind of a semicircle. Here this point is XC is 0. This is XC is infinite. That means XC is going to be 0 whenever C is infinite. This is C is 0. That is, this is the correct admittance locus diagram for the given network. Find the capacitance values for which resonance occurs. Here at the value of resonance, the admittance is going to be purely real. So means the imaginary part is going to be 0. If we make the imaginary part is equals to 0 in the above given admittance equation y of t, we will get xc square minus 11.36 xc plus 16 is equals to 0. So if we solve this quadratic equation, we will get xc as two values, that is 9.71 ohms, 1.65 ohms. So we know omega equals to 5000 radians per second. Xc is nothing but 1 by omega c. here C1 is 20.6 microfarad, C2 is 121 microfarad. That is option both A and B. That is option D is correct.
Now this is a linked question and statement is given as A is equals to 1, 2, 1, 4, 2, 3. Now the first question is we have to check which of the statements is correct. Now we know that every matrix will satisfy its characteristic equation. So the characteristic equation of A is nothing but A minus lambda I is equals to 0, which is nothing but 1 minus lambda 4, 2, 3 minus lambda is equals to 0. If we simplify, it will be lambda square is equals to 4a plus 5i. 4 lambda plus 5i, sorry. So it can be also written as a square is equals to 4a plus 5i, which is nothing but option D. We have to find a power 5 minus 4a power 4 minus 4a cube plus 11a square minus a minus 10i. Now, as it is a linked answer question, let us take the previous answer. Previous answer is nothing but a square is equals to 4a plus 5i. If I write it in polynomial form, it will be lambda square is equals to 4 lambda plus 5. Let it be some equation 1. Now, the given equation is lambda power 5 minus 4 lambda power 4 minus 4 lambda cube plus 11 lambda square minus lambda minus 10. In order to get the matrix, required matrix, what we do is I'll factorize this. If I factorize this, it will be something like lambda square minus 4 lambda minus 5 into lambda cube minus 2 lambda plus 3 plus lambda plus 5. Now, we have to factorize this in such a way that we can use this statement 1, that is lambda square minus 4 lambda minus 5 is equals to 0, so that the simplification will be easy. So I have factorized it. Lambda square minus 4 lambda minus 5 into some expression plus lambda plus 5. Now this will be 0 into lambda cube minus 2 lambda plus 3 plus lambda plus 5. So this is nothing but lambda plus 5, which can be written as a plus 5i. A is nothing but 1423 plus 5i is nothing but 5005. If we add, it will be 6428, which is nothing but option C.